Assalamualaikum and hi, we are from Group 8 for subject Engineering Geology. Now we are going to present about the Rock Tunneling Quality Index. Let's go! So first, what is Rock Tunneling Quality Index? It also known as Q system for rock mass classification that was developed at the Norwegian Geotechnical Institute in the 70s. Q system is developed to classify rock masses around an underground opening as well as for field mapping. A Q value for a rock mass can be determined based on estimation of three essential ground parameters, which are relative block size, inter-block shear strength, and active stresses. And all of these parameters are combined together to express the ground quality with respect to stability and rock support in underground openings in the following equations. The purpose of this study is to identify the rock mass classification system for Q system. The objectives are to carry out the critical review of Q system and to discuss and compare the different ways used to determine the Q value and Q system by the authors from the related studies. From these studies, we will be raising few questions. The importance of this study are
Now I will explain you about a case study which provide the comparison, the study design of content of the selected single or multiple case study that related to the Q system. First is a finite element study of the preliminary design of the tunnel support based on a RMR and Q system, which is established at 2014. From this report, it show a Q system design appear to work quite well, while the RMR system of support design appeared to be a conservative approach. The Q system support design was found to be less conservative and hence to the total deflection were higher than the RMR support system. The comparison the design obtained from the two system RMR system will be result in a more conservative design. The RMR support design system seems to perform better than the Q system design system. Okay, for the second case study is a review of the rock mass rating and tunneling quality index development, refinement, application, and the limitation. From the case study, show a RMR and Q system originate specifically for estimate rock tunnel support. The initial maximum value of stress reduction factor for the condition of competent rock with a rock mass problem was 20. The initial guidelines were for drill and blast excavate tunnel support and were based on the rock mass class in a turbulent form for a tunnel span from 5 to 12 meter. Q value, the equivalent dimension, and the actual support used for stability of the tunnel to classify a rock mass for its quality. Next is the S in a RMR support. RMR system, both spacing is a function of Q value and thickness of shotcrete is function of the DE along with a Q value. Okay, for the third case study is a tunnel support by rock quality index Q system for ultra basic rock, a case study in a Klupit Sabah Malaysia published at 2019. From the case study, it shows the RQD is classified as excellent quality because 88.1% of the discontinuities more than 10 cm in distance. The joint set number was rated as 15. The overall roundness has been given as smooth planar with 1 rating value. The joint water reduction factor was selected as dry excavation or minor inflow. Is lower than 1 minute. The discontinuities alternation is classified as experienced discontinuities softening or lower friction clay mineral coating. This category is suitable for the 1 value of stress reduction factor. The calculated Q value for permanent roof and wall tunnel are 1.4 and 3.5 respectively.
The title of the case study 4 is the optimizing the maximum unsupported span value by the Q system to enhance the production in the mining operation. Okay, for this case study, dia ada underground gold mine. Okay, this case study is the newly conducted case study because it received at the 2020. For the result, okay, combine is maximum range could be suggested with a length of 4.2 meter and the drilling bit could be modified to 84 millimeter. Okay, the drilling time was longer, but the output of the forward meter of drilling blasting were more than 80%. Okay, from that, by the utilize the MSU, optimize unsupported span, and considering the factor, the productivity could be improved and safety was guaranteed. Okay, we move to case study 5. Okay, the title of the case study 5 is the weight test effect during the back calculation of the rock mass quality from the installed tunnel support in the rock mass rating and RMR and the tunnel quality index system Q system. The case study is received at 2019. Okay, for the result, the effect for the result is determined about the effect of the weight test during the back calculation of the rock mass quality in terms of difference between the space adjusted with RMR 89 and RMR 14. Okay, next it also have determined about the percentage of frequency of the calculated about the RMR 14 and RMR 89 in different considering the 5 case. Okay, lastly, it also has determined about the effect of the weight test during the back calculation of the rock mass quality index value, which is Q, for the different range of stress ratio. Conclusion: the table 1 show that the comparison the study design and the content of the selected single or multiple case study that they relate to the Q system. Okay, it also show the achievement of the objective and the different result of each case study. Okay, for each case study have their own objective and they have passed all the objective. For the result, it have totally different with each case study. The result of the case study 1, it show the different about the application of RMR and the Q system. Which one is the better for using the design and the support on the tunnel. Okay, next, the result of the case study 2, it show the general application of the Q system and RMR to achieve the suitability, the quality of the rock mass, and the determination of rock mass strength in the tunnel design. Then the result of the case study 3, it showed that the calculation of the Q value for check the quality of the rock mass to the result of the permanent and temporary support, design requirement of the tunnel roof and the wall. Okay, next, for the result of the case study 4, it showed that the volume of the maximum unsupported span MUS using the Q system for obtain the characteristic of rock mass in the certain site. Lastly, the result of the case study 5, it shows that the different calculation of effect of the weight test during the back calculation of the RMR, which is RMR 89 and RMR 14, and the effect of the weight test during the back calculation of RMR index value Q for install the tunnel support.
Today I will be presenting to you about the application of Q system. To find the Q value of the Q system, there are 6 parameters that we need to be determined. Okay, the Q value equation is Q equal to RQD per JN times JR per JA times JW per SRF. The Q value is calculated based on 6 parameters, which are: first is degree of joining RQD, joint set number JN, joint roughness number JR, joint alteration number JA, joint water reduction factor JW, and last one is stress reduction factor SRF. RQD is a data that we get from drill core at site. The core pieces data will be recorded in RQD datasheet. After filling the datasheet, the RQD value can be determined by using the formula RQD equal to total length of the core pieces, which is more than 10 cm, divided by total core run length times 100%. From RQD value, we can use RQD table to define the rock classes. However, RQD value also can be determined by using the formula RQD equal to 110 minus 2.5 JV, which is JV is the number of joints per meter cube. For the joint set number, which is Jn, we will use the Jn table to determine the value by according to the number of joint sets and random joints. However, if the number of joint sets are difficult to be identified directly, the number of joint sets can be plotted in stereo net. Next is joint roughness number, which is JR. There are 3 steps to determine the value of JR. For the first step, we need to identify the joint surface profile. For the first one is type of wavy or undulating joint surface profile. Next is tapered joint surface profile and planar joint surface profile. For the second step, we need to determine the joint roughness of the surface profile. Okay. There are 3 types of the joint surface category, which are rough, smooth, and silicon-sided. For the last step is we use the JR table to determine the JR value using the type of joint profile and joint roughness.
Okay, next is to identify the joint iteration factor, which is JA. When considering joint infill, 2 factors are important. First, thickness. Second, strength. In the determination of the joint iteration number, the joint infill is divided into 3 categories, which is rock wall contact, B, rock wall contact before 10 cm shear, and C, no rock wall contact when sheared. Okay, fifth is to determine the joint water reduction factor, which is JW. Joint water was soften or wash out the mineral infill, thereby reduce the friction on the joint planes. Water pressure may reduce the normal stress on the joint wall and cause the block to shear more easily. A determination of the joint water reduction factor is based on inflow and water pressure observed in an underground opening as shown in table. When reduction between the joint water value 1 and 0.66, the flowing can be applied. JW equal to 1 for a single drop of water, JW equal to 1.66 for a trickle of small of jet of water. If a concentrated jet of water is coming out of a drill hole, JW equal to 0.66. Okay, and the last one is to determine the stress reduction factor, RSD. Okay, in generally, SRF describe the relationship between stress and rock strength. Now, an underground opening, the effect of stress can usually be seen on underground openings such as spalling, slabbing, deformation, squeeze, dilatancy, and block release. The stress and mass strength of the rock can be measured, and SRF can be calculated from the relationship between the uniaxial compressive strength of the rock and the major principal stress, or the relationship between the maximum tangent stress and compressive strength of the rock in the massive rock. To determine SRF, the category must be determined before parameter value. The stress situation is classification in 4 categories is according with table, which is A, weakness zone that intercept the underground opening, which is may or may not be able to transfer stresses in the surrounding rock mass. B, compacted rock with stability problem due to high stresses of lack of stresses. C, cruising rock with plastic deformation of incompacted rock under the influence of moderate or high rock stress. D, swelling rock, chemical swelling activity depending on presence of water.
The purpose of the study is to identify the rock mass classification for rock tunneling quality index Q system. The objective of this study that has been stated before is to carry out the critical review of the Q system and to discuss and compare the different ways used to determine the Q value and Q system by the authors from the related studies. In this study, several questions that has been asked before, and to answer or solve this problem investigated, all solutions can be determined through the case studies that has been discussed and compared. For the first question, the result of the case study showed that the type of rock and ground conditions the Q system covered are ultra-basic rock and underground gold mine. Next, to answer the second question is the type of support used does not affect the deflection in the system because the total deflections were higher than the RMR support rock bolt system and tunnel liner. Hence, there was hardly any yielding in the rock bolt and liner support, except for one case in the Q system was found to be partial yielding of the rock bolt system due to the higher total of deflection in the system. Last but not least, the third question is the behavior of rock masses is influenced by the mechanical behavior and properties of discontinuities of the intact rock bounded by the discontinuities. In conclusion, the objective of this study and the problems investigated have been achieved. Therefore, with a better understanding of the Q system, the quality of rock mass can be determined accurately and it indirectly allows the work to run smoothly.